On today's episode, I'll show you how I made this. A flashing LED on air sign. It's got a 3D printed case and a custom circuit board that I cut out on my X-Carve CNC. And there's no microcontroller, no Arduino. The components on the board, all total, cost less than $1. So I'll show you how I made this on today's Filament Friday. This is the circuit I'm going to use. It's got 2 transistors, 2 capacitors, 4 resistors, 2 LEDs, and a 9-volt battery. When power is first applied, current wants to run through these two resistors and turn on these transistors. But what happens is one of them turns on before the other, and that's what starts the oscillation. Let's assume this guy turns on first. When this guy turns on, this becomes 0.2 volts, or almost ground. So now the LED has a path to ground and the LED lights. The capacitor now also has a path to ground, so it starts charging. And when it does that, this voltage right here drops to real low, drops to that 0.2, but then starts charging up to the 9 volts. So because this is 0.2, this transistor turns off. And when this transistor turns off, this LED is off, and this capacitor has nothing to do. So this keeps charging until this reaches 0.6 volts. Now current starts flowing in here and turns this transistor on, which turns on this LED. And also starts this guy charging, and this becomes 0.2, which shuts this transistor off, and therefore the LED goes off. And this capacitor stops charging. So now this is running, and then while this is charging, when this hits 0.6, it does the same thing. Turns this transistor on, drives this down, LED comes on, ground, and this guy goes off, this guy goes off, and it just does this back and forth continuously. I like to breadboard the circuit first to make sure everything works. So here it is all built up, apply power, and it's working perfect. To make the board, I use ExpressPCB. Now this is an older software, but I'm so used to it I keep using it. 2 transistors, the LEDs on the outside, capacitors on the inside, and then the resistors here. Now for the traces, I had to make these a little bit wider because I'm CNCing. So I did a 40 thousandths trace, and then for the pads, I did a 0.1 inch diameter with a 0.035 hole. So this gives me enough material that I can router it. Now I need the Gerber files to produce the board. Now if you use KiCad or Eagle, it'll produce the Gerber files. But for ExpressPCB, I have to import it into Copper Connection, a third-party software, and then I can export the Gerbers. Now once I have the Gerber files, I can use a software called Flatcam to produce the Gcode. So I open the bottom layer, and here you can see it. And now I need to do an isolation layer. I got to have it route out this traces. So I select the file, and now I got to change the bit to 0.020, which is the size of my bit. And then I just generate geometry, and that produces another file. And that file I click on, and this is where I set the settings to cut out the board. How deep to go with the z-axis, the travel, the feed rate. Basically I leave it set to the default, generate the file, and you can see now this is where it's going to cut out the little motes around to form the traces. Now once I have that file, I click on it and say export Gcode. And I save that as layer1.gcode here. This is what I'll actually import in to control the CNC. But I'm not done. That's just the outline of the traces. Now I got to actually drill the holes. And here you can see I imported the drill file, and it's got all the locations where the holes are, but it's easier if you see it against the traces. So you can see all the holes are right in the center of the pads. So let me get rid of that layer file. And so now I have to set up this in the Gcode. So there's a 0.035 drill, and I just say generate it, and now it knows where it's going to drill in the order it's going to drill. So once I've got this set up, I just got to click on that file and generate the Gcode. So I click on that, generate Gcode, and I'll save this as the flasher_drill.nc file. The final step is to open the Universal Gcode sender. This controls my XCarve CNC. I connect to it through the USB port, And then I open the file that I want to cut, in this case the layer1.gcode. Once I have that, I can actually visualize it and make sure I got the right file, and it's going to cut it out the way I expect, and it shows that it's gonna. So that's good. Close that, and now I can send this to the XCarve. The board itself has a copper layer and then material underneath that's non-conductive. So all it's doing is cutting through the copper to form the traces down into that non-conductive. So it's forming a moat around all the traces. And once it's done, I just need to clean this up, and then we'll go drill the holes. I go back to the universal Gcode sender, connect through the USB, but I need that NC file, the flasher_drill.nc. NC is numerically controlled. And the green shows where it's actually going to drill the holes. It's not really clear here, it's kind of crude, but clearly that's the file I want, so I send it to the XCarve CNC. Now before I started this, I changed from the router bit to a drill bit, a .035 drill bit. And then I zeroed it, but you can never seem to get it perfectly on, so the drill holes are slightly off of the pads, but it's good enough. So I finished that, and now we're ready to check it. I took a little sandpaper to the top of it, and then I had to check with my multimeter to make sure there were no shorts to the extra copper. Everything looked good, so now I need to cut the board out. I used my sheet metal notcher to cut the board, but you could use a bandsaw or a hacksaw, but this thing just cuts it like butter. Once I had my board cut, I just needed to insert the components. They're all inserted, and then I bent the leads underneath to hold them in place so they'll stay while I solder them. And then I just need to solder to the copper, and then I'll cut all the leads, and we should have a completed board. Then I need to test it. All the components are soldered in place, including the two LEDs, which I had to solder on the opposite side because they're going to go through the case. That was a little bit difficult to do, but I did it. I connected power, and it worked just like the breadboard. So now I needed to make the case. I created the case in Tinkercad. What I did is actually imported an on-air sign that someone had on Thingiverse, which has recessed letters, and I just added the holes for the LEDs and a hole at the top for a switch. And then underneath, I put a battery holder, which I also found on Thingiverse, blended that in, and then did a little knockout for the board, and then just put this edge around it. And that was it. Pretty easy design, so I downloaded the STL and imported it into Simplify 3D. So here it is. I click the Edit Process Settings. I'm going to print it on my Flashforge Dreamer in PLA, 25% fill, 5 top and bottom layers, 8 perimeters. I am going to use a skirt and brim to hold it. Temperature-wise, 210 degrees and 60 degrees on a platform. I click Prepare to Print, and it said it would take 3 hours and 38 minutes and 22 meters of plastic. And here's the finished print. I cut off the brim, and this thing looks really good. Flashforge Dreamer did a great job. Holes are round, letters look good, and the battery holder is outstanding. So this design is ready for the electronics. I soldered a battery clip 9 volt to a switch. So the positive lead comes into a switch, then goes to the board, ground goes right into the board. And then I added 2 little strips of double-sided foam tape to hold the board to the box. So now I can just test it. I have an on-off switch. Now I need to just assemble this to the box. Here it is fully assembled. The battery slid in nicely and it holds tight. That clip worked really well. I got the battery clip on. The switch just went through the hole, and a nut on top holds that tight. And then the double-sided tape holds the board in place so the LEDs can pop through. And I put a little white paint on the letters just to make them a little easier to read. If I did this again, I'd probably do a 2-color print. So now the test. And we're on the air. So that was a lot of fun, and I enjoy putting electronics into my projects. After all, this is Chuck Hellebuck's Electronic Products. 3D printing and Filament Friday are just part of the channel, and it's what I wanted to deliver plus more. It's just time is my limitation. That's why I'd like to see more support on Patreon, so eventually I could do this full time. Now, you don't have to CNC your own board. You can just get any standard circuit board at Radio Shack or whatever electronic shop is near you and just solder it up yourself with some jumper wires. What I like about using the CNC and the software for the board is now I have a design I can send off to production if I wanted to turn this into a real kit and have production boards made. I got another request for a Filament Friday sticker. This time it's from Jerry Nielsen. He sent me a self-addressed stamped envelope. So Jerry, I'm going to send you two. If you want a Filament Friday sticker, just send me a self-addressed stamped envelope at the address in the description below. Projects like this definitely take more time, but I really enjoyed it and I hope you did too. If you did, give it a thumbs up. If you like what I'm doing here, please subscribe. That way you don't miss an episode. And if you want to help support projects like this in the channel and get me to that goal of doing this full time, there's a link up here somewhere to Patreon. $1 a month is all I ask. I have many people who give more, but I need more support, so I'm hoping you can help. So that's it for this week. I'll see you next time on Filament Friday.